Hello, my name's Vince Cobley from the Land Rover Owner Adventure Club. Most people never go off-road driving because they think they could damage their vehicle or they think it's too difficult. At Land Rover Owner magazine, we try our best to assist the readers in every possible way when it comes to off-road driving. In this film, we're going to try and demonstrate to you the techniques and skills required to ensure that your off-road driving be safe and adventurous. We're going to start with the two basic four-wheel drive systems. This is how it all started, a Series Land Rover. Part-time four-wheel drive, which means the rear axle's driving probably for a lot of the vehicles 90% of the time. It has the capability to push a lever which will transfer via the transfer box in the gearbox. 50% of the drive will come to the front axle, which means we now have an even 50-50 split. 50% of the drive is on the back axle, the other 50% is on the front axle. This, however, is its modern day equivalent, the Land Rover 90 Defender, permanent four-wheel drive. You don't have to think when to select the front axle, it's already selected for you. To understand the technicalities of this one, however, we're going to be coming back to this vehicle a little bit later. So, when do we use four-wheel drive? For most people, as I said before, we're driving down the road in rear-wheel drive only. If we came into a site like this, if we lived in certain parts of the country where it had been snowing or that has got the capability to have snow, we may need extra traction at certain times of the year. But it's not really rough terrain. So we engage four-wheel drive in the high gearbox. As I said before, it transfers 50% of the drive to the front axle, but it does not change the overall gear ratios. However, if we came into terrain like this and then moved over onto what the sections that you can see over there that we'll be going into later on, hills, steep drops, climbs, axle articulation sections, deep mud, water, we need the capability to alter the torque figures of the vehicle and to go a little bit slower. So we have another lever that we can use. That is the low gearbox transfer lever. We do that, we have to stop the vehicle, and it changes the gear ratios within the vehicle. Third gear in the low gearbox is the equivalent gear ratio to first gear in the high box. However, a common misconception is that the word four-wheel drive means that all four wheels rotate evenly at the same time. We're now going to move this vehicle and we're going to show you that with the aid of suspension and the differential, this is wrong. Okay, now we've repositioned the Land Rover, let's try and show you what a differential does. This is the wheel. The wheel is attached to the axle. The axle has a differential, which is a load of gears really inside the axle. They distribute the drive left and right via the half shafts, but their main objective is to allow one wheel on an axle to rotate faster than the other. Ray, if you can just show us. As you can see now, we're in part-time four-wheel drive. Ray's driven away, but we're going nowhere because the differential, unfortunately, has sent the drive on the back axle to the wheel with the least resistance. If you can see, the far side wheel isn't rotating at all. It's stopped. We have got a one-wheel drive. Okay, Ray, now what we're going to show, we're going to put it into four-wheel drive. The common conception there is that all four wheels rotate evenly at the same time. Now, as you can see, we've engaged four-wheel drive, but the front wheel's not turning, and as you can see diagonally across the car, the rear wheel's not turning. We've in fact only got a two-wheel drive car, but it's the two wheels with the least resistance. Later on in the programme, we're going to try and explain to you a little bit more into that, about the terrain and about how a suspension affects that. Now, there is one problem with part-time four-wheel drive on hard surfaces. If you leave it in four-wheel drive for too long, you cause a problem that's caused transmission wind-up or gearbox wind-up. Let's go over here and I'll try and explain to you what causes transmission wind-up. Okay, as you can see in this conveniently muddy area, we just brought a vehicle through here and turned it on full lock. And as you can see, we've got four wheel marks. 1, 2, 3, 4. These are the wheels on the right-hand side of the vehicle, the offside. These two over here are the wheels on the inside. This is the front wheel, this is the rear wheel. Front wheel, rear wheel. So as you can see, even the two wheels on the same side of the car are travelling in a different radius. But you can also see by the 4 wheel marks, these are the 2 front wheels, these are the 2 rear wheels, that the actual wheels on the back axle are actually turning a shorter corner. So let's say, for instance, that the vehicle here, that the front wheels are turning a 20-foot turning circle. The back wheels, however, are doing an 18-foot turning circle, which in reality means that the gearbox should be sending out the front prop shaft rotated at 100 revolutions, but the back one really needs to go out at 80 revolutions. But it can't do that. It's trying to distribute it out evenly. And because of the traction of a 4-wheel drive, what tends to happen is that the gearbox main shaft actually winds up. It physically starts to twist. Now, it's fine off-road if it does twist, because when you're in the mud, in the snow, a wheel will spin now and again. It will unwind itself. However, if you forget, leave wherever you've been off-roading, Welsh mountains, a quarry, if you forget about it, get onto the main road where you've got lots of grip with the weight of a 4-wheel drive, the wheels cannot unwind, they cannot contra-rotate, and eventually something shears in the transmission system. It'll be the weakest point. It could be a half shaft, or it could be the teeth and the gearing in the differential. So, be aware of that. Be aware that if the steering becomes heavy, what's causing that? Have I got a puncture? Or is my transmission wound up? Am I having problems changing gear? Is the car decelerating quicker? They're the sort of signs that you're looking for. But unfortunately, there are no visual signs as such. You can hear it sometimes. You can hear the back wheel trying to contra-rotate, trying to spin backwards to unwind itself. But earlier on, we mentioned the Land Rover Defender 90. That's a permanent 4-wheel drive vehicle. Why doesn't that get gearbox wind up? Let's go and show you now. Here we are back at the Land Rover Defender, the successor to the series Land Rover, permanent 4-wheel drive, which means the front and the back axles are permanently driven, as opposed to the series Land Rover, which only has rear-wheel drive and you have to select front-wheel drive. So if both axles are driving, why doesn't it get transmission or gearbox wind-up? It's because built into the gearbox of this model is another differential. And the differential in the gearbox works exactly the same ways as the differential on the axle. Whereas the differential on the axle distributes the drive left and right, the gearbox differential distributes the drive front and back. It allows the vehicle to turn without the shafts in the gearbox winding up. Let's try and just show you how that works. Okay, Edward, if you could just start the car, please. As you can see, we've only got 1-wheel drive. So what's happening there? Go back to the middle again. Now, what's actually happened is that the centre differential sent the drive to the axle on the vehicle with the least resistance. In this case, it's the rear axle. Then the differential on that axle has sent the drive to the wheel with the least resistance, giving us 1-wheel drive. How do we overcome that? Simple. These cars have a high and low gear lever. The high and low gear lever can be selected on the move. You simply push the lever across to the left and it locks the centre differential. That is all it does. It's a bit of a misconception because some people think it locks it all up. It doesn't. It locks the centre differential up. It automatically distributes the drive and gives you 50% drive at the front and at the back. Ed, if you'd just like to show us that, please. Just put the gear lever across to the left. It's distributed out. As you can see now, we are back in the same mode as the series Land Rover. 1 wheel on each axle, the wheel with the least resistance. And that is the best we get with this model a vehicle. But progress. We now have come to the point where we've got rid of the part-time four-wheel drive, where we have to think about putting into four-wheel drive. They gave us permanent four-wheel drive. But people still have to think and know when to put that diff lock in. However, the new breed of vehicle has a viscous coupling gearbox. Let's try and show you how that works, because that does the thinking for you. Thanks, Ed, if you can change the vehicles.